the milling toolpaths to start off, and some of the new features that they've kind of put in here. One of the nice ones is in the dynamic type of toolpaths. They've put it in what we call the region chaining preview, along with a couple things as far as max stock engagements and previews of some toolpaths and some raster motion, things like that. So kind of getting in with the region chaining preview. Again, these are going to be on your dynamic 2D dynamic paths here. And inside of the chaining options, if you were to take a look, you'd see now a little button on the very bottom where it says Preview Chains. I have a little quick video here for you where if you take a look and we tell it our machining region and kind of tell it our containments and stuff, sometimes it might be a little hard to see exactly what is going to be cut, and before you know it, maybe your toolpath is airing out and stuff. So now we've added in what we call that Preview Chains, which is again just that little tick box down there. You can click on it, and of course you can also modify the colors. And that's basically telling you what is actually going to get machined, what is air, and where is the tool going to be contained here as well. You can see if I do end up modifying some of those chains with some air regions or containments in, say, Preview Chains, how that is going to get changed. Again, of course, being the red and the black is where we're going to be cutting. The blue is going to be more or less the air region, and kind of the yellowish gold color is going to be our containment boundary. So kind of very nice and helpful before we actually get into toolpath and see what's going exactly on with it. Now back in X9 here, we did put in some options as far as the preview toolpath. That was going to be in your simple contours and things like that. And now we basically put that into the 2D high-speed toolpaths as well. So it looks like a couple people are not able to hear me here. The
broadcast is now starting. All attendees are in listen-only mode.
Can everyone hear me now? If you can you raise your little hand icon to the side here? If everyone can hear me, can we use the little hand icon? Okay, that's better. Sorry about that. Had a little technical issue here. So I'll start back from the top again. Matt, do you want to restart the recording? Recording here for the YouTube page. All right, so now with everyone hearing me, of course, if you do have any questions, of course, make sure to, as most of you were using the questions icon, we'll just hop open to our YouTube page here as well. If you do have any videos you want to check out on our YouTube page, that's going to be our username here. We do have yesterday's rollout already on the YouTube page as well. If you missed that, or if you wanted to check something out in there as well that Matt did. Kind of getting into who we are, we have Jeff Ingston. He's going to be our president of ShopWare here. On the sales side of things, we're going to have Matt Sump. He's going to be our Illinois sales. Todd Rathkamp is going to be our Wisconsin sales. Myself, Reimer Mell, we're going to be in the Iowa and Southern Illinois sales. And then, of course, Kim Clapper is going to be your inside sales. As far as technical support, training, or post-processors, we have Norbert Radzikowski. He's going to be our technical manager. Scott London is going to be our training manager in applications. And then we have Josh Proctor and Joe Pisciferato, which are our applications engineers. If you need to get in touch with us, we have our toll-free number of the 888-222-7126 number there. Or if you need to email us in anything sales-related, it's going to be sales@shoprank.com. Or if it's a technical-related question, if you send it to tech@shoprank.com, that'll go to all the apps guys here as well. Just a little itinerary here for the morning. About a little after 10 here to about 10:45, we're going to be going through the milling enhancements. From 10:45 to 11:30ish, we're going to be kind of going through the lathe, mill turn, multi-axis, etc. from there. And then, of course, we'll stick around from 11:30 to about noon or so for any questions and answers that you guys may have. So kind of diving into our milling toolpaths as first, obviously there's quite a few changes that were made along the lines there. Starting off with one of my favorite ones is going to be the region chaining preview. They have done some things as far as consolidating some stock. If you've used the 2017, you probably noticed some of these already. A couple things with the Toolpath Preview and the maximum stock engagement as well, of course. So kind of getting into the region chaining preview, there's going to be a little button on the very bottom of the chain options here, and the chain options is basically going to allow us to see exactly what is going on here. I have a little quick video here for you to watch and see. So when I put in my machining region and maybe I put in some containment and air regions, things like that, sometimes it's a little hard to see exactly what the toolpath is going to be wanting to cut, where can it go freely within the air regions, things like that. And so what we did here is we put in the preview chains, which you can see where the red and the black shadings are. That's actually going to be what's all cut. And depending on what chain options I put in here for the air regions or containments, those are going to be modified on the fly here so we can see exactly what's going on. So instead of you going through and kind of guesstimating what's going on and getting an error at the end of the toolpath, now we can kind of see exactly if we have a bad chain, where the bad chain is, and what we can do to get exactly what we want to cut. Another nice enhancement here is our Toolpath Preview. Back in, I want to say it was X9 or so, we put in a preview toolpath as far as, some pockets, contours, things like that, pretty standard toolpaths there. However, now we have added that into the 2D dynamic toolpaths here. It's going to kind of help you out and see what exactly settings are doing and where your toolpath is going to be cutting even before you get out of the toolpath itself and you green check out. So it kind of helps you verify all your cut parameters, your settings that you have set up initially here. And of course that's going to be in all the dynamic toolpaths under the high-speed menu. Another thing as well here is what we call the dynamic line of sight. So if you're familiar with using the dynamic toolpaths, there is what we call the back feed rate motion, and the back feed rate motion sometime in X9 wasn't the most streamlined and to the point there. Kind of jumped around a little bit. You can kind of see it going over that wave, things like that. And so what they did with the 2017 here is kind of added that in so it's a little bit more aggressive and a little bit more to the location it needs to go to. It's not going to kind of bounce around and go and play it super safe. It's going to go right to the point, and this has been tested a lot of times. There's nothing you have to do inside the toolpath to make it active. By just regenerating, it's taken in all the new algorithms and things like that for it to basically go directly to the location it needs to next instead of dancing around. So those were kind of some X9 moves here. Some 2017 moves you can see is going straight there, and to the point. We're not jumping around and doing a lot of wish-washy motion. Obviously, it's extra motion for your machine to interpolate there too. So again, nothing much you have to do with that on the settings. Is more or less just regenerating your toolpath and using all the new algorithms there. Some of the Raster Motion, we've added in a quick new tick box here that's going to tell it to do a perpendicular fill, so you can see if we're doing just a standard motion here of along the y-axis there, it's going to do a quick perpendicular fill in order to get all the extra area there. So there's basically a couple ways we can set up the toolpath. We can do the perpendicular fill on the cut parameters page there. You can see the toolpaths, what I have set up is anything from 0 degrees to 45 degrees is going to be one motion, and then of course I can come into the perpendicular fill, turn that on, and do basically from 45 to 90 degrees as well here. So a couple ways we can base that toolpath, or the third one I had set up here is where we're going to do everything together from 0 degrees to 90 degrees with the perpendicular fill on. And if I were to backplot that, you can kind of see the motion that we're going to be doing here. So we'll get out of those screens there. And you can see we're going the one way right now, keep going back and forth. And then at the very end, we're going to use that perpendicular and finish everything else up. Another thing too is kind of consolidating some of the pages here. We have put on the trim to stock and the rust material, of course, on its own stock page. It's going to be right up front for you. Not sure how many people use what we call stock models yet, but stock models are very nice and can help you out a lot as far as when you're wanting to compare, the stock to what we have left. Maybe you're coming in with a big tool hog and everything out, and then of course you want to come in with a small tool and just clean up certain areas. Again, the stock model is going to assist with basically creating an in-process model of exactly where we have stock left. And we can base the toolpath right off of that. That way we're not doing extra air cutting or any other motion that's not really needed here. So you can see if we went into that stock page, we do have the rest material. We can tell it kind of what do we want to compute it from, and that's going to be computed in the toolpath for us. Another nice feature is the maximum stock engagement. This would be in a toolpath such as like a waterline. Again, it's going to be on your cut parameters page here. It's just a option as far as the maximum stock engagement goes, and of course we can compare that to a stock model. And basically with it, it's going to be protecting any smaller type of tools, possibly come in there with a big tool again, roughing a lot of things out, but yeah, you have some small corner radiuses in there. Well, instead of taking a tool and basically doing a full engagement inside of there, we have an option where we can say the maximum depth we want to go is this amount, and that way, even if the pocket is deeper, we're only going to still go that maximum depth with the tool. They have improved some scale-up of the performance here, a little bit faster with the regeneration, kind of with the multi-threading manager, multi-core processing, things like that. And of course, that's going to save you time with the regenerations and the calculations of those tool paths. That kind of wraps it up as far as the 2D and the 3D goes. I'm going to go ahead and open up the next one here for you guys, and that's going to be getting into the lathe. And again, if you have any questions in the meantime, definitely make sure to write in. Matt's going to be sitting here and answering any of those for you guys. But kind of getting into the lathe toolpaths, there are a good amount of features as far as compensating for any live B-axis machine heads here. Kind of bringing in some of the mill turn type of windows into the lathe, and of course some new features inside the roughing toolpath as far as chip rate goes, and aligning any solid bodies to the correct axes. So getting into the tool nose radius comp here, added in some changes as far as how we're going to compensate the toolpath and the tool to that. If we take a look at a little quick video here, we can of course set up the tool angle that we need to run it at. But if you take a look at the compensation line, they're not exactly correct. And so by making a change here and using the option that we put in for the manually define the cutter direction, it's more or less taking how we set it up on the machine and we're translating that more into the software. That way we do get the proper compensation here on the part. One of the nice features that I do definitely like in Lathe here is going to be the aligned solid body. Here's a quick little video. You can see if we go to like a right side view, a top view, even a front view, we're not really lined up in any particular plane in this instance. So it is going to be under the Lathe tab under the utilities, and it's going to be called aligned solid body. What we're basically doing is selecting on a cylindrical face as first. We can of course take that and line it in as we need to on that axis. And of course we can also clock in the x-axis as well in case we need to clock it into a specific feature. Once we say OK, we do get a little window here where I can either create a brand new WCS off of that, or I can actually transform it to an actual plane itself. And by doing that, we're going to be creating either, like I said, a new WCS or bringing it to my plane. And it's just a quick, easy way to bring that versus doing like a dynamic transform. And that's going to line it there. Another thing too is the stock boundary, they call it. So you may have noticed before here, if we go in with some lathe toolpaths and then we go in with maybe a mill toolpath, some of the stock may not update exactly, and so when we come in and do, let's say, like a boring operation on this part, it's going to be colliding and telling me I'm actually colliding with my stock. Of course, I know that I went in there before with a drill and basically cleared everything out, and so what we can do is basically create a stock model inside of the lathe. We can reference what our initial stock is going to be looking like off of a particular toolpath. We can create a boundary off of that, and that way when we create our toolpath, the toolpath is going to reference off that boundary, and it is going to compensate properly, and also you can see it's not going to be overcutting any extra air motion there. So now we're trimming it exactly where I had that drill go in there. Another thing too is going to be under the plane creation and the selection of it. They've kind of brought in some of the mill turn style of menus inside of there, so if you ever need to mess around with your axis combination, that is all going to be under here as well. They did kind of get rid of that coordinates button there, so everything is going to be packed into the axis combination for you to make changes for it. A nice addition to the roughing type of toolpath is what we call the chip break. Heard a lot of good things on this, but if you're going to be using your toolpath and it's really giving you kind of a bird's nest with all your chips, the chip break is an option in here. I can basically come in, I can tell it a couple of different options as far as how long do I want that lead in, lead out to go out for. Distance-wise, I can tell it how much do I want to dwell in there, and then of course how often do I want to do the chip break itself. And again, it's just going to be a quick little tick box under the roughing page here on the bottom right-hand side, and of course we can go in there and make all the changes we would need to. By green checking and either creating our toolpath or regenerating our toolpath, it's going to take all that into effect. There's nothing special we need to really do besides just setting it up inside the parameters. So as you can see, if we put in our values that we want and create that toolpath, you can see now where our retracts are going to be lining up here. Also works as well for the contour rough, which was a new toolpath back in X9 here. So it's always going to have that functionality there for you. If you ever need to, there are some easier options as far as creating relative planes to certain ones. So that has been an addition inside of the planes for the lathe side of things. So again, that kind of wraps up the lathe side of toolpaths for us here. Again, if you have any questions, definitely let us know. Otherwise, we'll keep going with the multi-axis. With the multi-axis, a lot of the improvements have kind of come into consolidating a lot of the toolpaths kind of together, getting more users more or less into the multi-axis world, and really helping out the workflow, usability, things like that to it. So, of course, they have added in some nice features as far as the drilling and circle milling, selecting our points, things like that, some additions to the multi-axis linking, and of course, like I said before, the toolpath consolidation there. So with the toolpath consolidation, if you ever looked at the multi-axis tabs here, there's a lot of toolpaths that were basically the same type of toolpaths. It's more or less, are we picking off a wireframe geometry, or we're picking off of edges of surfaces. And so now what we've done is we've added those together. That way we have, for instance, just a morph, versus in X9 we had a morph between two curves, morph between two surfaces. It's going to help out. And of course, inside of the actual toolpath itself, we can tell it the differences of what we're going to be picking. Again, kind of stressing the stock model here, we have added the stock to the very top of the list for us there. So before, you may have had to dig a little bit for it with a couple little plus signs that would cascade out to different menus here. Because stock models are pretty important, and there's a lot of usability to them. We basically put that nice front up and center for you guys to use right away at first. And again, we can put in stock models. We can use the toolpath off of that stock model and adjust it accordingly from there. Going a little bit more into that consolidation, there's where I said the morph between two curves, morph between two surfaces now into just a morph. 3 of the parallel types of the toolpaths are now into just a one parallel. So there's really going to be 4 main categories as far as the multi-axis programming goes. And you can see those 4 are just going to be the morph, the parallel, along curves, and multi-surface. With the toolpath consolidation, a little bit more to it. Before they did have a like the toolbox in there, so couple modifications we've done with those. Again, not very useful toolpaths in the most case there. Kind of how they restructured the cut pattern page here. Like I said, since they did add in the toolpaths together, you can see now we have the options to pick off of surfaces or curves, or in this particular toolpath we can pick off a certain angle. And we can see how all those would take into effect there for us. Again, no changes we have to make on our end to do that. Some new options with the collision control here. We have added in where we can go ahead and use the stock to leave and also a tolerancing on the drive surfaces. Before we had to just do that as a check, but we can use that with the drives now in 2017. And of course we can also always set up multiple sessions of the collision control on our strategies. But now I have the options to use the stock to leave and the tolerancing for my drives and or checks. A little bit reorganization and restructure to the linking page here. A little bit different of menus, of course, as you can see it. We have added in the what was before on our linking pages and some of the little plus signs underneath those all onto the one page there. So again, nice and easy to go ahead and pick on that and use them without having to dig into some of the menus. Again, with the roughing, before we had to go to a roughing page, we had to turn on if we want to have depth cuts, and then there'd be another tick box if we want to have a multi-passes, and each of those would have different menus. So now under roughing, it's going to consist of all the roughing strategies that we have inside of the Mastercam multi-axis toolpaths, and they're all there quickly and easily, so you can go ahead and modify those on the fly as needed without having to dig for them and look for them really. Same thing kind of goes for the utility page. Again, kind of adding on things together. That way, again, we don't have to search for it. They did add in kind of a newer style of toolpath called our Advanced Rotary. It would be good for any rotary type of parts that you're wanting to consistently spin your rotary with. And if you kind of take a look at the toolpath itself, it's going to be under the gallery there. Of course, we can go ahead and tell it all the information as far as the model we're going to use, kind of the strategies we want to use on our cutting, step over, step downs, all that good stuff there. And then of course we can see once we pick that model and say OK, we'll see what the toolpath is going to look like here. So give us something like that. If we were to bring that into verify, you can see it's going to be a nice, smooth toolpath that they've added in. Some other nice things as far as the toolpath goes is with the drilling and circle milling. So some more automated ways to use that. It is going to be now stock aware, where it's going to be basing its toolpath off of that type of stock there. Also with that, a couple enhancements as far as how we can select those holes. Of course, beforehand we had the options for lines, points and lines, points, things like that. But now we are able to add in what we call features. So if you did have a a solid model, like you can see on the screen, and instead of creating what we call like a whole axis first, we can actually go ahead and pick those on the fly, again saving time. So a couple different methods we can use there as far as the selection. If you want to select anything that has the similar size hole in there, to mass select everything. And of course now we do have the calculate the depth from the incremental from that. Now if you do end up creating a whole axis on that piece, so we do get all the center lines to it, again we can go ahead and automate more or less that selection feature by either windowing, selecting that, and you can see if we pick the lines we can window select and pick exactly those lines that we need to versus going in and picking one by one. Tool axis control page, some point and line associativity, so it's basically going to be referencing off of that for us as well there. Next is going to be kind of the mill turn and code expert. With the mill turn, there's a lot of technical types of bulletins to it. So let's do a raise of hands if anyone is using the mill turn, and if that's something that would be possibly beneficial to go through with. Otherwise, we'll kind of fill the time with some other types of tips and tricks and things. In the meantime, too, what we're going to do, since we're waiting for those hands, we're just going to launch a poll here. It's going to be what version of Mastercam you are using. So if you don't mind answering that for us. And it's not going to be 2017 beta, it's actually just going to be the standard 2017, just to clarify on that too. So it looks like most everyone's voted, so appreciate that, of course, as always here. We will kind of go through the mill turn since I was able to see a few hands being raised here, so we'll kind of go through that with the code expert, followed by the tool manager, and then we'll have some live Mastercam files to fill some time at the end there. So kind of getting into the mill turn, definitely a lot of stuff coming into play here, and enhancements along the lines as well. Of course, being the multi-session, so before in X9, of course, if you try to fire off any multiple sessions, it would give you a little warning saying, hey, you know, we don't support it, but now, you know, everything is going to be supported for multiple sessions at one time there. As far as the job setup, of course, when we get into the mill turn, you are going to be made to go into the job setup so we can pick our geometry, our raw stock, kind of creating our turn profiles off of that. How do I want to set up my jaws and all that good stuff. So they've really kind of gone through and changed around the organization to it to kind of better assist you with everything and being a little more efficient as far as how you're going to go through that with us. Some of the workflow to the mill turn tool manager setup has kind of helped out as well. So of course, as some of you may know, with the mill turn you can actually load the tools onto your simulation of the machine. So it really helped us out with the workflow there as far as how we're going to go through and process the tools, getting them loaded up onto the machine, we call it, and going from there with it. Some of the filtering and loading up the tools, you can see it's a little bit easier to sort by the turret and all the tools. Again, saves you some time as far as assembling your tools and your holders, together, and really simplifying a lot of things to your tool setups this way. We do also support some of the multi-station and half index locations as well. So if that's something you guys are possibly using, it is going to be some of the new features inside of here to support some of that more complex mill turn machines, as far as how you would set it up and getting exactly what you have on the machine into the software, so you can prove it out and make sure you're good to go the first time around. Some of the machine tool setup as well, you can see some automatic tool loading with some drag and drops. We can bring it in and we can load those up on the machine into those proper index locations there. Again, some of the half index options as well. As far as the tool display goes, of course, they are going to be reflected, all the changes we make inside of the software into the machine simulation. Pretty easy to see all the mounted tools that you currently have on the machines as well. We are able to modify and kind of drag and drop some of the projections here to make it quick and easy for your tool setup, and see exactly what changes you're doing on the machine in the machine simulation, that is. And of course we can modify any of that projection by just doing the right click and going to the properties menu to modify everything there. Again, pretty quick and easy to reorient any tools and adjust the numbers that are needed, and of course we can see those on the machine simulation as well. As far as your reference return points, sometimes that can be definitely a big deal. Those are going to be in there, and of course we can put that in with the gantry and charts and everything to help, again, reduce cycle time and extra motion that's not needed. We are able to default those as well. That way, again, it helps you out down the road. Some of the sync manager has been kind of redone here. Of course, Milturn's going to be using the Mastercam Code Expert, so they've added in some things as far as when you are doing the sync manager here, we can look at the part, we can rotate it, we can unzoom, zoom in, things like that, where before we weren't able to really. So a little bit more flexibility and user control using it that way. Again, with all these additions into the machine simulation, kind of gone in and made machine simulation a lot more accurate, added in the turret support for the C-axis offset there. We're going to be matching the Code Expert display settings, and we're still going to be showing the tools that are not necessarily used in the operations there, along with the multi-station tool support. A couple things as far as improvements to the tool mill's radius compensation here, as far as the job setup with the jaw positions and things like that, and of course unwinding and winding up of the tools. Kind of getting into a little bit of the Code Expert here. I know some people like to use the Code Expert, some people like to use other editors as well, but with the Code Expert they have added in the multicolor support here, so you can see that depending on what codes you're running, they are going to be different different colors there. We can kind of tailor those to your individual needs as needed there. There are some options as far as kind of marking your tool changes, so it kind of gives you a quicker, better, easier way to see where those exactly are inside of all your code. If anyone needs it, there is multi-language support now, so supports more of a wider range of languages inside of that code expert, kind of helping out across the product there. So that kind of wraps up as far as the code expert goes there. We do have also the tool manager, of course, which has a good amount of changes in here as well. So kind of getting into the tool manager for the Mastercam 2017, there's going to be a couple things as far as some new tool displays, kind of the workflow inside of the tool manager, and some new tool support that we've added into here as well. Back in X9 we did have in the barrel mill, and so we've made it a little bit more accurate as far as the compensation of that specific type of tool here. You can see if we're doing this style of toolpath with our tool, how that's going to compensate all the way back and forth. Again, having some changes there to the tool manager. We do have some new support for the high feed type of end mills here. So with that, jumping ahead on a slide here quick, but if you take a look at that, we are able to bring in the CAD type of file from either Sandvik, Iskar, Kennametal, whoever the tooling manufacturer may be. Typically they'll have some type of model of it. We can bring that into the software, we can compensate for it properly, and add that in as a tool. That way we can check and see inside of backplot and verify as well. Again, with the barrel mill support, kind of some additions to that as well, as far as using that barrel mill in a couple of different ways there. If we do end up going with a right-click and say, edit tool, of course we can import that model of the tool inside of here, and you can see if I were to use that tool path, we can take a deeper step down with fewer passes and, of course, shorter cycle times. Some of the slot mill support we've added in is going to be being fully aware of the shoulder, so I can kind of collision check against that. Of course, we can also use some of the quarter treatments on the very top and bottom of that as well, being added in there. One of the nice features that I like is what we call the dynamic tool projection here. If we were to take a look, I should have a video here, and with it, if you're not sure exactly if your tool is going to be colliding with your part, obviously if you're wanting to have a small stick out as much as you can, if you go in to verify and see that we're colliding with our part itself, what we can do is if we go into our tool path, we can do a right click on our tool here, and we can see exactly where that tool is going to be in projection to the part here. So you can see right now inside of verify we are colliding with that part, in fact. And so if I do end up going into my tool page do the right click on it and say Edit Projection, it's going to allow me to drag that tool around inside my part to see exactly where I'm going to be at as far as the depth and if I need to modify the projection that we're sticking out there. Of course, we can also go to different views to see how close we are, and like I said before, we can either fine-tune it on the fly there, we can even type in the numbers if needed to as well, and adjust it, and the toolpath is automatically going to get marked dirty, and everything is going to be changed automatically for you inside of there. So once I say OK, bring it back into verify, then we're going to be good to go. So now you can see we're not even close to hitting on any of those islands there. Some of the other new custom tool displays is really going to help you out again, kind of going in and bringing off those CAD models from any of those tooling manufacturers. Really help save time and get you an accurate tool to what we're going to be viewing here. So that kind of wraps up the tool manager here. Of course, as always, if you guys have any questions, make sure to read in and write in on those. I'm not seeing anything just yet here. So we're going to take a minute here and we're going to pass it over to Matt, get his screen showing up here, and we're going to do kind of some mill stuff as well with the Mastercam files. So just give us a minute here. I'm probably just going to say.
Okay, don't make me the presenter yet until.
Should just say stop showing my screen.
No, I'll just leave it on just so you know that we're not like doing anything weird. Hardware. Okay.
That's better.
Oh, I know. Already. All right. Hey guys, this is Matt Sump here. Thanks for showing up today, and thanks for Ryan for going over through all that stuff. And hopefully we didn't PowerPoint you to death, but I'm going to go over through some specific part files here for some of the topics that Ryan covered, and is hopefully going to be useful to you guys because we're only at about 10:50, and we reserved at least an hour and a half. And I had a 2-hour block on the email blast that I sent all of you. But thanks again for coming. A couple of things, if you guys weren't on the webinar yesterday, if you want to download the 2017 release, without linking your Mastercam account or anything like that, you can go to our website, shopwareinc.com, and then right on the front page here, we have, click here for what's new in Mastercam 2017. And it's going to be kind of an overview page with a link to the what's new. But if you click on go to 2017 download page, I've already entered the password, but the password is always our company name, ShopWare, lowercase, as well as whatever the current version is. So it's ShopWare 2017, and that gets you on this page. You can download 2017. I have some training PDFs on there, power libraries, some of the new tool libraries on there, the Mastercam command finder, which is basically like a Google Live search for any of the commands in 2017 to help you transition over. I have a custom workspace here where you can basically, and if you watch our recording from yesterday or we're there, you can have specific tabs pop open when you pick like a mill machine def or a lathe machine def as opposed to what the default tool library is. And we also have some training materials on this page that's kind of more in-depth 2017 training that's from Mastercam Corporate. And then lastly, we have the utilities for the license manager for NetHasps and things like that. So let's get into some files here. I have a bunch of sessions of Mastercam open. First, Ryan was talking about that maximum stock engagement. So I have the part that you probably saw in the video there, and I have this kind of a standard waterline toolpath here. And if you notice, waterline would always go in there and it would cut as deep as possible into that corner. And if I turn on my stock model here, you'll notice that these ribs have quite a bit of material in there. So, you know, if I'm going in there with a 1/2-inch ball end mill at my current speeds and feeds, you know, I'm probably going to overload that tool and over engage the stock. So if I go to my next toolpath here, which is the other one, which hopefully it'll show up on the webinar and enough for you guys to see, but you'll see that tool's not going in there, so it's not going to overload the stock. And you'll see here where, you know, we're only removing a little bit of material, but we're getting closer to our net shape on where the tool is not going to be over engaging. So if I go into my parameters page here and then go to the stock page, it's right at the bottom of the stock listing here. So you basically tell it, okay, what stock model do I want to look at? And then what do I want my maximum engagement to be? So it's a really easy setting to do, and then you can basically kind of go your workflow from there on creating additional stock models, doing another tool path, like we're doing just an Opti rest based off of that rough, so we're not necessarily doing another finish pass, but we're using the kind of the combination between the waterline and the stock models to, you know, safely engage the material and rough out from there. So you'll see, so the kind of the combination between using the waterline, the stock models, and then an Opti rest toolpath, which if I go into the Opti rest parameters here, on my stock page, I have compute the rest material from one other operation, and it's looking at that stock model, which was after the waterline with the maximum stock engagement. And I'm also telling it to, and this is another setting that I don't think a lot of people know exactly what it does, but to summarize, it's going to basically look at that stock model, and you can tell it to either use it as it's exactly computed, or you can kind of get rid of some extraneous motion by telling it to what's called ignore small cusps. So like these little, if I go back to the stock model here, oops, if I turn it on, you'll see here, like, because we're not quite doing our full finish yet, so we're going to have little scallops on, let's say, like the outside of the part here. And what that setting does is it basically ignores those little scallops because maybe I'm going to go back with another finish tool path to really get to my final shape for a mold or whatever the part may be. And I can basically put in that distance of what I want those cusps to ignore. And you'll kind of know based on your settings from previous tool paths on what to set that cusp height to. And there might be a little trial and error there too to kind of get as clean of tool motion as possible. But you guys will see there between those two tool paths, you know, I'm getting pretty close now to where I have most of my stock removed, and then I can go into like a rest tool path to kind of clean up the rest of the part. But that's my spiel on the maximum stock engagement that Ryan was talking about. What else do we want to get into here? Let's talk a little bit about that new Raster Motion that we added in 2017 here. So before, if I was doing a raster toolpath, I would have my along toolpath here where it's going basically back and forth across the part, and using the high speed advantages of the raster toolpath, where it's going to have nice smooth motion leading on and off the part. It's going to use the multi-cores to process, but then I'd have to go back in here in my parameters page, and if I go to cut parameters here, I would basically edit my machining angle to 90 degrees and have to create an additional operation. But if I go to my third toolpath here, this is using the new settings in 2017, and it's a real simple switch in here. So if I go back into my parameters, and I have to remember to wait because the GoToMeeting isn't as fast as I like to move around. So if I'm going too fast, someone just raise their hand or type in the comments saying, hey, Matt, you're going too fast, and this is annoying. But if I go into my parameters page here and turn on that perpendicular fill, really all that's doing is, within the same operation, adding a 90-degree machining angle to the raster toolpath. So it's a real easy setting to use and can cut down on, first, the number of toolpaths, and I think kind of open the door for people to utilize the raster toolpath more often, because basically the raster is the old surface finish parallel that everyone would beat to death in the old Mill 3 toolpaths. And that is a question as we're talking about the Mill 3D toolpaths here, because if you look in the kind of the standard toolbar and you open up the Mill 3D, you see some of the old toolpaths in there, like surface finish blend. That is the old school toolpath, but a lot of the other ones aren't in this gallery that Mastercam created as a default. So you can do one of a couple things. You can create a custom toolbar that has all these new toolpaths, or if you didn't know, if you right-click in the operations manager and you get this really long list of all your different options, import, export operations, edit common parameters, things like that. But at the very top of the menu is the mill toolpaths, and this is where you'll see basically the toolpath layout from X9 and previous. So if I go to surface finish here, I have the old school parallel, the old school radial, and all those other toolpaths. And I also have all the wireframe toolpaths, because basically, and this has been part of dealer feedback, because Mastercam at first says, oh, let's just get rid of all this stuff and have everyone use the high speed. Well, anyone that's used Mastercam a long time, some of those old toolpaths do have some additional flexibility and basically use cases where the high-speed stuff may not be the best fit for you. So we told Mastercam, hey, we've developed these toolpaths. We know they work. There's really no point in getting rid of them. It's not making the install of the software bigger, really anything like that. So basically, if you ever can't find a toolpath in the new interface, just right-click in the operations manager and go to mill toolpaths, and you'll see basically the format of the old toolpath set up and basically get to whatever you need to. So that is the raster motion. What's up next here? Oh, the region chaining preview. And I have a couple things to talk about with this particular file. And I have this file again in kind of a more of a tip and trick approach as far as programming goes. But Ryan was talking about the previewing. So if you notice my preview here, and I can set the colors to anything I want. By default, red and black is a crosshatch of where I'm telling it, okay, you're allowed to cut here. Anything that is blue is basically free space for the tool to move within. It's not necessarily going to go all the way out to where that blue region is. I'm just telling it, you're free to move in there. I don't necessarily have any work holding in that area, and so forth. And then finally, the yellow is the maximum containment of where that tool is going to be. And if you remember on your tool containment page, you also have the option, do you want to stay inside that containment, right on it, or allow it to go, the width of the tool outside the containment. But basically what I'm telling it here, and I use some of the new features in that we added in X9 as far as the solid linked edges are concerned. And I basically chained around from the beginning here. And as opposed to, since there's no geometry connecting there, I just continued to link the edges down and around until I got to the edge of the material that I wanted to cut there. And what a lot of people don't know is this open chain extension to stock. So if I hit preview here, you guys saw exactly what I was getting with that setting. If I say none, ignore stock and hit preview, you'll see here is it's not really looking at my stock definition, and it's only thinking to machine areas that are fully enclosed by what I picked to toolpath. If I select it to tangent and hit preview, you'll see that tangent will basically allow it to extend infinitely beyond my edges of what I chained to cut. So you basically want to kind of take a look at this, and I think it's kind of some, not really trial and error, but some practice on what these different settings do, because this new chaining dialog box, and this is why we added the preview function into here, because before, when you use this new chaining dialog box, you would have to get all the way to the point where you created the toolpath to kind of see what these new chaining options allow you to do. So now that we added the preview in here, you can really kind of quickly go back and forth on what these different options do. If I added an air region here, or, drew some wireframe and added a containment, how does that affect my basically 2D high-speed toolpath motion and where I'm allowed to cut? So I definitely recommend, because this is going to be good for both training and also I think experienced users on getting even a little more power out of this new chaining dialog box. So since we've been talking about this wing rib file, let's look at my other example I have of this. So I have this kind of programmed two different ways. So say you're a Mill 2D customer and you get a lot of parts like this, and you are used to programming it, feature by feature, picking pocket by pocket. And we've seen a lot of customers upgrading to the Mill 3D to basically take advantage of that dynamic OptiRest function. So the OptiRough toolpath that's in here, and let me turn off that custom toolbar I was showing in yesterday's webinar. Go back to the standard toolbar here. So the way you'd program this with, say, Mill Standard or the old Mill Level 1, you'd pick pocket by pocket. But when you go into the toolpaths here, and Dave Canigliaro, who will be doing the tips and tricks session at the Customer Appreciation Night, which is Thursday at IMTS, it's from 5 to 8 p.m. You can sign up right on mastercam.com, or you can sign up in the booth any day during IMTS, and we'd love to see all you guys there. But what he told me, because we had some dealer training before 2017 came out, and he said, think of OptiRough as always a rest pass type toolpath. So it's going to be its most effective and reduce the amount of air cutting if you're always using stock models when you use OptiRough. So in this first example here, I have an initial block to define my stock. I do an OptiRest only up to a certain depth, and then I kind of go from there. I can add stock models based on individual pockets, and then it'll do toolpaths just for those areas. And this first section is kind of how one of the AEs at corporate, because if you follow Mastercam on YouTube or any of the social media stuff, they did kind of a test cut of this particular part, kind of showing some time savings. And I have a PDF here. Let me try to find it. Email, Mastercam 2017. This tech sheet, which we're starting to do, we call it our manufacturing lab, where we can show, basically the advantages of the high-speed toolpaths and what they can do as far as cycle times, improving tool life, and really all the other benefits that the high-speed machining can do. It has a link to a video. You can download the part file right from Mastercam and kind of see what we've done to utilize that new technology that's in the software. So he basically goes through here and kind of programs it, one by one, and assign stock models for every area, and that can kind of take a while to program. So what Dave over at Corporate did was what he called the lazy shotgun approach. So we'd still start with our initial stock model here, but then we tell it to OptiRest the entire part based off of that stock model. And so we're really completing the same thing that, I can't remember his name, Jesse did with 8 or 9 toolpaths and got it down to essentially 2 toolpaths. So I take my stock model from there, and you'll notice, I have some of these bottom pockets still left to finish. I have material left in the corners still. And then I basically just go back in there with a smaller tool and tell it to OptiRest, the rest of the part with a tool that's the proper size to get in all the corners, get in those smaller pockets in the bottom. And I have my stock compare turned on here, which is an option in the stock models. So I have basically my first tab of the stock model is my defining, okay, I'm looking at my rough op previous to that, and I am using just looking at the OptiRest toolpath right before that. And then my third tab here is kind of like what you would get in Verify, but doing it at the stock model stage to do some compare on, seeing what I have left to cut without having to go in and wait for Verify to calculate. So I'm basically getting to my net shape here with just a couple different tool paths. So I definitely recommend for you guys to, and if anyone wants this file, shoot me an email after the webinar here, and you can see some of these examples. And another file from the in-person rollouts that a lot of people wanted me to send an example of is something that we call power cutting. So a lot of the feedback from the dynamic tool passes, they're great. I'm getting better tool wear. It sounds awesome on my machine when I'm cutting these, but it's covering a lot of distance. I'm only taking a small, between a 8 and 15% XY step, and I'm taking that deep step down. But let's pull up the file I have here. So, and turn on display only selected ops. So this is kind of what I would call a traditional high-speed tool path here. So if I go into my parameters and go into the cut parameters, I'm doing a 10% step over. I am on my linking parameters here. I'm doing a full depth of cut. This is a metric file. I do have an English version of this, I believe, as well. But you'll notice here, and I do have all my speeds and feeds set up because this file was helped on us by the Sandvik people, and we're using all their new Plura end mills, and I'll get into that into a second here. But if I go into my backplot and get my info on actual cut time here, we're looking at about almost 4 minutes of total cycle time for this particular operation. And if I go into the backplot here, you'll see it's taking the small step overs, full depth of cut, and utilizing that dynamic tool path. So the way I describe this is there's kind of a 3-horse race as far as manufacturing technology goes. You have the machine tool manufacturers, you have the tooling guys, and then you have us, the software people. So as people make progressions in technology, machines went from the old ball screw to, like servo drive, and the machines, as opposed to being, big hoggers of the 80s and even into the 90s, they went into, not necessarily as rigid or robust, but the machines can move a lot faster. The rapids got up to really high speeds and things like that. So then the tooling manufacturers caught up with that, and then the software people come out with tool paths that can utilize the speed at which the modern machines can move at. So the kind of next progression of what's happened here is the cutting tool manufacturers were like, okay, all the CAM guys are coming out with these tool paths using the radial chip thinning technology and all that sort of stuff that comprises a quote-unquote dynamic tool path. The other guys have similar stuff. You've probably heard of volume mill, or there's 1,000 different names for this stuff out there. The Mastercam stuff, actually, we've been developing in-house since about 2008. There was a guy in Germany that basically had a patent on this technology, and we bought the source code, as where something like volume mill is still a leased version of that technology, and then they're kind of reliant on that to implement it into their system. But all of our stuff since '08, and we've branched off from everybody else, it's all developed in-house right there in Connecticut. So if I go to my internet browser here, I'll use Sandvik as an example just because we've been working with them recently, but I know ISCAR, really all the other kind of names you'd hear are coming out with tools that have this sort of technology to do what we've called power cutting. And essentially what that is, to simplify it and it's as short as I can, is you're basically doing dynamic tool paths but with a traditional type step over. So you'll look on the right half side of the part, this is a mirrored part where it's the exact same geometry, where it's using one of their new Plura end mills. And if I go to my cut parameters page here, I'm doing a 70% step over as opposed to a 10%. And what that comes down to is the tool you're using, the machine's capable of it, and you have the right tool holder. So, because there's going to be a lot of, the tool's going to want to pull out basically. So, like a hydraulic holder or like a shrink fit, similar to that. But if I go into my back plot here, and if you look, my cycle time is only 1:27 for the same geometry. And what you'll also notice here is on the old school, or not really old school, but the traditional dynamic tool path, I'm running at, what's my spindle speed here? Oh, yeah. But I'm basically running at a higher spindle speed. I'm at 9,600 on the traditional dynamic tool path, but we're actually slowing the spindle speeds down a bit to do this what's called power cutting. So, I'm only at about 5,800 RPM, and this is going to be good for, maybe you only have an 8,000 RPM machine, whereas, the traditional way to do dynamic, really the more spindle speed you have available, the better it's going to be. Whereas these, every example I've seen is somewhere between 4,000 and 6,000 RPM. And this cheater file that I can send you guys, we have all different kinds of materials pre-programmed here. And I have some of my comments turned off in my operations manager, but it also has the part number of the specific Sandvik tools used. But, we have some 4140 in here, 1018, there's a stainless example, and then I think finally at the bottom we get into, some like titanium nickel sort of stuff where a little more exotic materials. But let me go to our YouTube page. I'm trying to see if I have an example here. These are liked videos. Mastercam power cutting, Mastercam. Where is that video, Ryan? Here we go. Let's open up this guy here. Hopefully this will come through okay over the webinar. But this is the dealer out in the Pacific Northwest. It's a MA Ford brand tool on an older Akuma vertical doing some power cutting. And we ran some demos of this on the Doosan at the TMA here in Chicago. But it's a similar, and if I skip back here, yeah, here we go. So, and this is actually this part that I was showing you guys on the screen here. But so you're going at a slower feed and speed, but your material removal rate is almost more than double the traditional way to do dynamic tool paths. And if any of you guys are coming to IMTS, which reminds me, I should probably launch that poll now. I didn't do it yet because it looks like everyone that signed up for this is still in the room. So where are my polls at? View, polls. Let's see who's all coming to IMTS here. But I know in the Akuma booth, oh, I don't have that poll on this webinar. Sorry. Got ahead of myself. I forgot to transfer the polls from the webinar yesterday. But hopefully you guys are coming. And a bunch of the different machine tool manufacturer booths will have some of these power cutting examples at the show. But does anyone have any questions on that power cutting? I haven't really seen any questions pop up. But just shoot me an email, matts@shopwaring.com, or you'll get some follow-up emails from me after the webinar where you can just reply and say, hey, Matt, send me the files that you were talking about. But that's the power cutting example. What else do I have here? Oh, another kind of tip as far as using these stock models is what a lot of people don't know is when you go into a stock model, and if I go into the parameters here, I don't necessarily have to, do it off of a stock definition or off of a previous stock model or even a file. I can basically tell a stock model to only go off of, say, an individual solid face or a group of solid faces or a group of surfaces. And I can use that to my advantage with like any of the mill 3D toolpaths that allow the use of stock models. So like Waterline, high-speed pencil, I believe Scallop does. The only one I know for sure that doesn't is the hybrid, because the hybrid wants to look at the entire model and finish it from there. But basically what I'm doing here is, let's say I have a pencil, 3D pencil toolpath for this. Now, if I do pencil by default, it's basically going to analyze and say, okay, I'm using this size tool. These are the radiuses on the part that I can clean up and machine fully. So let's say on this particular part, it's not critical as far as machining the radiuses of this entire part. I really just need to clean up in this pink circle that I have, or pink area that I have defined in the part here. So if I turn on the stock model display, I have the stock model, and I'm kind of cheating it, I guess, for lack of a better word. I'm basically adding 2 thou worth of material on just these surfaces here on the inside of the part. And what I can do is, if I go into my high-speed pencil here, you'll notice now I'm only doing a pencil pass on that stock model extra material that I told it to. So if I go into my pencil parameters here and go to my stock page, you'll see I'm telling it to use as computed, which we were talking about that before. And then I'm telling it to trim to the stock and look at that kind of dummy stock model I created. So it's going to know then to force this pencil tool path just to those areas where I assign the stock model. And I've seen a lot of customers, since I've been telling people about this, using this to their advantage to basically force any sort of finish tool path into areas that they specifically want to cover. I actually stopped out at a customer in Elk Grove the other day, and they were getting a really long cycle time on their UMC 750, and I was kind of showing them this trick, and they went from 3 to 4 hours on this aerospace part to just about an hour, because they were able to cut down on all the error cutting that they were doing, even using stock models prior, but they were basically forcing it to only finish the floor of this part because necessarily the walls didn't need to be as precise. It was kind of this cam bracket thing that they were able to use, that kind of picking individual faces on a stock model to limit the tool motion. So I certainly invite you guys to kind of try that out and see what sort of results you can get from that. That's my blurb on what I call the noisy pencil. And let's talk a little bit. Ryan was talking about that tool projection. I just kind of wanted you guys to see it in action. And I would say as we just came out with this, it's not as fully featured as personally I would want it to be. We have some enhancement requests with Mastercam after using this in practice a bit. But if I go to this Contour 2D toolpath, you'll see it's kind of on a horizontal machine or maybe a 5-axis where I have a tool coming in and around the part. And I need to be careful with how close my holder's getting to the part. And this, in case you guys weren't able to see on the video Ryan had, when you have your tool menu list here in the toolpath, you right-click and you say Edit Projection. So it's going to kick you into a basically live view of the tool on the part, and it will use the snapping functions that are built into the solid models. So let's say the deepest I can get here to the part is if I go to, let's say, a front view, I can pick that location there that's basically, let's say, a little bit past the depth of what my toolpath is going to be. Now this is going to pop up with you in prompt, and then these are the areas where I want them to add some enhancements is, let's say I edit this tool projection and it's starting to collide with the part. They're going to be adding in here where the holder is basically going to see where there's geometry, and it'll basically turn red when it's getting too deep. Because right now it's basically a visual sort of tool. It's not necessarily something that's going to squawk at you when you're going to be hitting something. But what you can do here is see how it adds this additional red line as I drag away from the projection. So what I can do here is say, okay, 6.3 is about the top of my part here, and even 6.35, let's say, is the top of this outer extent of my work holding. So I can basically type in here and say, okay, 6.5, I know for sure will clear the part. So there's a little bit of kind of visual tools in there, but once I go in there and edit that tool like that, if I go to my holder page, you'll see that this value is now updated as to what my tool projection is going to be. And you can use that really in any toolpath now in 2017. So while it's not, as fully featured as I would like it to see, it is a tool I think that can help people, so you're not kind of guessing as far as what your tool projection should be like you had to in X9, or get all the way to the verify step before you see, okay, hey, my holder's bashing through the corner of the part here. I should probably modify my toolpath before I send it out to the machine. Did they add tool projection to verify? I can't remember. I think they did. But I think you could try that in verify as well. I'm not sure if they added it. One thing I did want to talk about with Lathe, as I just think you guys want to see this in action a little bit, because this is extremely helpful, and I think a lot of people don't know. I believe it was X9 added support for stock models in Lathe, where before, you were limited to the old Lathe machine definition. So if you have any sort of lathe that has live tooling or like a mill turn style machine, you can really use that advantage of the stock models to reduce error cutting and ensure proper tool clearance on really any sort of live tool lathe. And I actually had a customer out in Rockford that was making some automotive like transmission coupler parts, fairly similar to this part that I have on the screen, where they were using a surface finish waterline and using this new stock model function to basically eliminate air cuts and also limit that waterline toolpath so it's not overcutting or exactly getting to the part shape that they want it to be. So let's say I have a lathe rough toolpath like this. I just go into stock model, and on my stock definition page here, there's a new option that'll pop up when you're using any sort of lathe or mill turn operation, and that's this lathe operation function here. And I can look, and it's going to name it by the name of the operation. So by default, it's going to be lathe rough, lathe contour rough. But if you edit that name in your ops manager, because I know people might have 100 operations in their file, you know which one to pick based on what you named it. So I click on lathe rough here, so it's going to look at that particular toolpath. And then I just click the box here to create a stock boundary. Now, this is grayed out because I'm only on the left spindle here. But let's say you had a part or a machine definition or a mill turn machine def that had a main and a sub spindle, it would allow you to pick which side you were working on. But it'll say, okay, I have to give it a name or it's going to yell at me. We'll call this stock model 1. And I say, okay. And then it's basically going to compute in the background. You know, you'll see my little multi-threading manager there. And in a second here, after it analyzes the model, it will create then that stock model for my subsequent operations. And like all the stock models, you know, you have control over what you want the tolerance to be and so forth. But then I can start going through here. Once I have then that created, I can start going through here and start using my live tools or like my upper B head to start machining some of those features. So we are at 11:30, which is what I said the time would be. So we're going to open it up for questions now. If anyone wants to ask anything that I covered or Ryan covered. And we will have the recording on our YouTube channel, which we have the one from yesterday. We already had 105 views. I was really surprised we had 12,000 views for our preview X7 or 2017 webinar. YouTube actually sent me an email if I wanted to monetize the videos, which I don't need to do that. And also, if you guys watch yesterday's webinar on YouTube, I did some of the tips and tricks that I did over lunchtime at the in-person rollouts. If any of you guys are from Wisconsin, which I do see a couple of Wisconsin guys in here, we are still trying to line up those Wisconsin locations. DMG Maury won't let us host the event there until they know for sure that they can have a machine on the floor and do some demos. So you guys say, hey, you know, maybe I want to talk to my boss about buying a new Maury. But we're also working with First Technologies, which is the Mastercam reseller up in Wisconsin for educational. And we're hopefully going to be doing a couple schools up there. I believe one in the Madison area and then one in kind of the Fox River or the Fox Valley, Oshkosh, Green Bay corridor there. So we'll hopefully have kind of all three main areas of Wisconsin covered. But I don't see any questions coming in, so I'm going to stop the recording for YouTube.